Back. So how did you like that EKS demo by Rick? Good stuff, right? Well, I wanted to be the first to let you know, if you haven't been watching Twitter or the news or whatever, we just opened the doors today on our new Stockholm region. And in Stockholm, you can now spin up ECS and EKS containers there as well. So you have even more options available to you as far as region selection goes. So the second thing that I wanted to mention, last night, local time, yesterday, Seattle time, we unveiled a roadmap tool. Let me drop out of my presentation real quick. And on GitHub/AWS, there's a project called Containers Roadmap. And this project, you can see we have a bunch of issues created where we've categorized them into we're working on it, or coming soon, or just shipped. So if you've ever wondered, hey, what's happening, what's going to be happening, scroll through here first. You'll see, at the top of the coming soon list, and these are in no particular order necessarily, other than being bucketed into those three big buckets. But you can see that we're, coming soon, Seoul, Tokyo, Singapore, Sydney, and Frankfurt region. So, we have region expansion happening, and if you want to see what is the definition of soon, check out the readme.md in this project, and it'll define what soon means for us. And it'll define we're working on it. What does that mean for us? So definitely check that out. If there's something that you think you would like us to work on, like to put on our radar, explore opening an issue here and let us know. And we'll see about how we can prioritize it. This is a brand new process for us, so there's a chance that it could change. Hopefully there's a chance that it'll improve. The goal is to improve visibility from my team outwards. So we'd like to eliminate or at least reduce the instances where you work really hard for a long time to solve a particular problem that you're having, and then a few weeks later we come along and we just eliminate that problem altogether, and all the work that you've done is now just useless. So we don't want you to have to spend a lot of effort if you know that, hey, there's a solution on the way. So definitely review this and see if this is addressing the concerns that you have or the areas of interest that you've been thinking about also. So I just wanted to point those things out before we get started. Now let's go ahead and dive into ECS. So we've looked so far, we've done an overview of how are all the ways to run containers. We've done a bit of a recap on some recent announcements, and we've done a deep dive into EKS. Now let's look at a deep dive into ECS and what's it like to run containers on ECS, and what are some ways to do that. Again, I think we're all friends now. So this is a little bit about me, but you probably already know most of that anyway. So what are we going to do with this talk? We're going to deploy a set of microservices, not a Twitter analyzer, but just a different set of microservices, and we're going to do it using ECS. So let's talk first, let's deep dive on the key components of really any orchestrator, but then we'll apply them specifically to ECS. With ECS and with any orchestrator, the way we like to work, the way humans like to work, is to think about how do we want things to be, right? You don't necessarily think about all the little steps to get there. That's what you do next, right? But you start off by just thinking about, what do I want the final picture to look like? And so we think of that in terms of that's the description of the end state. The end state for an orchestrator we like to push the end state to the orchestrator and let the orchestrator figure out all the little steps necessary to get there, right? So the end state for us is a task definition. That's a description of how we want our container to run. How do we execute this container? What does it take? What ports does it need to listen on? What containers does it need to pull down? A task definition can actually be composed of multiple containers. Sometimes you'll need two containers to work together, and they'll always need to scale up and down together. Maybe there's a sidecar, maybe there's a proxy or something like that. So in those situations, we always want those things to go out together, scale up together and down together. So we describe them as one task definition. We describe it to the ECS control plane. So the ECS control plane is something that we just make an API call to. We write our task definition into that control plane, and then the control plane processes it and comes to an understanding of, let me look at how things are today, right now, and let me look at what you just described, and let me figure out what I need to do to get there. And then it goes and it makes those things happen. So it will queue up actions, and it will deploy those actions out onto whichever cluster we happen to be working with. So today, the cluster can include Fargate. And as I said earlier this morning, every cluster is a mixed cluster. So we can have some actions, some containers, some task definitions that deploy out onto EC2 instances, and then we can have other task definitions that deploy onto Fargate. And ideally, the Fargate ones are the ones that you're using the most of, because those are the ones that you have to do the least with, right? You don't have to worry about patching or scaling the underlying infrastructure or anything like that. So if we stop for a second and we think about AWS services. At AWS, we give you many ways to accomplish the same goal sometimes. If you need to run a database, you can run it on an EC2 instance, or we offer a service. If you need to run a container, you can run it on an EC2 instance. We offer you a couple of different services that are managed. You can bring your own service if you like and orchestrate containers that way. So if we drew a box, and that box was how much are you responsible for and how much is AWS responsible for, and we put a line down the middle of it somewhere, we could just always be dividing up the same set of actions. This is what AWS will take care of for you, and this is what you will take care of yourself. And at the lowest level, we would have, I'm going to use EC2. Right? I'm going to launch EC2 instances, and then from there, what are we taking care of? We're going to take care of the underlying infrastructure, the data center work, the power, the networking, and stuff like that. And then everything from the operating system and up, you'll take care of. You'll take care of patching the operating system, installing your control plane software. Someone earlier today told me that they were using Nomad as their control plane. I'm not picking on anyone. I love Nomad. But I think it's a really cool example because there's a specific use case that led them that direction. And so they have that opportunity. They have that option to be able to run their own control plane and manage their containers that way. So that's really cool. And then as you decide, you know what, I want to hand over more responsibility to AWS, I want to do less work, right? That's what I think. I want to do less work because I want to focus more on the application itself at the top. So as much underneath that as I can, I'm going to hand off to someone else and let them take care of. So we can start to think about, what is the control plane doing for me? It's scheduling tasks. It's launching containers. It's evaluating health. It's understanding how to do a deploy. So all of those things I could manage on my own, or I could move that line up a little bit and use a different service, and now that's managed for me as well. So I could move it up and start using ECS. And I could move it up a little bit and run Kubernetes myself, or I could move it up a little bit more and use EKS. Or maybe I don't want to even think about scaling control planes or worrying about the cluster itself, or I just want to think in terms of just run my containers, move it up even more, and now I can run on Fargate. So as we look at all of these things, just keep that in the back of your mind. Keep that mental image of, who's responsible for what, because ultimately all the same actions have to occur. It's just who's going to be responsible for it. So with ECS, with the control plane, AWS is responsible for all of the cloud operations, security, patching, scaling, monitoring, availability, cost control. We take care of running that control plane and paying for it and making sure that it's up and available. What are you responsible for? Deploying your applications. So there's just a simple API call that you can use to deploy your application out onto ECS. And that's really all you have to worry about. Same thing with ECR. What are we responsible for? What are we taking care of that you don't have to worry about? Monitoring ECR, monitoring your registry, scaling it, availability, and then of course patching. So these are all things that are just taken off your table. You don't have to worry about doing them anymore. If you want to run your own registry, on the other hand, you have to figure out all of these things also. And then in addition to those things, you still will have to figure out, how do I deploy it, how do I pay for it, and how do I keep it secure. Container instances, now you'll see when you're running container instances, the bulk of the work is still in your column, right? It's still in your side of the box. You have to figure out, how do I deploy them? We give you tools to help. You have auto-scaling groups. How do I patch them? Rick alluded to it in the last talk, but we actually publish the latest AMI to an SNS topic. You can subscribe to it and you can build automation around it, so you could potentially automate that. How do I scale auto-scaling groups? How do I manage the cost? You have reserved instances and spot pricing. How do I monitor them? You have CloudWatch alarms. And then how do I make sure that I have enough available? Again, auto-scaling can work there. But it's all on you to sort of build all of this in, right? So this is where you're going to have the most effort when you're using a container orchestrator. So I've alluded to a few of these already, but what are the building blocks when you're managing instances? When it comes to each of those categories on the last slide, look at the tooling that you have that you can build your own automation around. So for deployment, you can describe your entire deployment using CloudFormation, or you can just run a CLI command and deploy some instances. It's completely up to you. You can even write your own, using our SDK, write your own scripts and make API calls using the SDK. Security, we have things for you like IAM. We have Inspector to hopefully tell you when something is sort of abnormally configured. It's not the standard way to configure things. And then we have VPC flow logs to hopefully notify you or alert you when things are behaving weird. Excuse me. Patching, update your AMI, replace your instances. By the way, I love that this is on the slide and not run Chef or Puppet to update your instances. Has anyone adopted, at least for their container fleet, has anyone adopted immutable infrastructure? The practice of immutability? I see a few hands, a little hesitant still. Okay, cool. Immutable infrastructure doesn't mean infrastructure that is read-only. It doesn't mean I can't write to it. It simply means I am choosing to not mutate its configuration. So if you think about the old way of doing things with instances, especially in a config managed way, Chef, Puppet, Ansible, Salt, all of these will take an instance and they will move you from one version of that code to the next version of that code. Then you make another change and move to the next. You go from A to B to C to D. Well, along the way, you might think, I'm going to undo something. But you don't write the reverse code to actually back it out, or sometimes you do, but usually you don't. I'm going to need this package, I'm going to need package foo installed. And then later you think, no, you know what, I didn't need foo installed after all. So you just take it out of the list of packages to be installed. Does that remove it from the instance? No, it doesn't. It's still there. So then someone else comes along and they write something and they say, oh, look, foo is here. I don't need to add it to my list of packages because it's clearly added somewhere else. So they just go ahead and they write their code with the expectation that it's there. And it works. Everything is great, right? Everything continues to work, perhaps for years. And then all of a sudden you have to completely replace an instance and you bring it up from scratch and it comes up and it's broken. It can't work. And you have to spend a long time troubleshooting why. Immutable instances, on the other hand, always start from scratch. And you configure them from 0 to production ready on boot every single time they come up. And then you don't touch them again. So I think this is a really beautiful concept, and it's made more practical today because the instances themselves that we run containers on the instances are so simple. All you need is the kernel, the Docker daemon, and sometimes a config for whatever agent you're running that's going to connect you into your cluster. That's it. So as long as you can do that, and you can do that in user data, then every boot you can have a fresh instance perfectly configured every single time, and you know with certainty that you can completely replace your inventory anytime you feel like it. It's a really comforting feeling. So I encourage you to start looking in that direction. Don't start with databases or something hard. Don't start with like container instances or something easy, because there's technology that makes it easy for you to adopt. So on the instances, we're going to run tasks in containers. So these tasks, what are you responsible for? You're responsible for the deployment of the task, describing how they get deployed, and then monitoring and availability, describing or having knowledge of, what is important to know that this container is healthy. We will take care of scaling, we'll take care of security, patching, logging, we'll take care of all that stuff for you. So let's talk about deployment for a second. What are your options with ECS for deployment? You can start with the console. And in fact, if you've never used ECS, I would encourage you to start with the console. The console is a terrific discovery mechanism. So start by building a task here, launch it out onto a cluster, see that it's running, think about all the choices that you had to make to get it into a working state, and then tear it all down and figure out, okay, now I'm going to go script this, or I'm going to go automate this and make it, sort of part of code so that I can hand it out or reuse it. So from the console, I might, queue up a task, define a task definition, and launch it. And then from there, I'll figure out, okay, well, what do I need to do? So in this particular command, we're doing EC2 run instances, and we're bringing up an AMI that is designed for running ECS. It already has the ECS agent. It's probably one of the official ECS AMIs. And then the one piece of config we're passing in is user data, ECS cluster equals whatever my cluster name is. And we're setting that into the config ecs.config. This is it. This is all you have to do to configure an ECS agent. The agent itself is a container, so you don't even have to really install any software other than just the standard Docker pull, Docker run type stuff. And that's done for you if you're using our official AMI. Now, if you want to use your own AMI, you certainly can. Just make sure that it has Docker installed on it and running. So deployments, they should be self-contained. A self-contained deployable unit. They should be repeatable. Every time I issue a new deploy, I want to make sure that this goes out. I want to make sure that it's the same every time. They should be auditable, and they should be self-documenting. So it should be really easy for you to see how is this deploy going out. So you might include some information like, when I deploy my second round of containers, I'm going from V1 to V2. Should I kill all the V1 containers and then bring up all the V2 containers? Sometimes yes. It sounds brutal. You maybe shouldn't always do that. But for example, if your containers are running a Kafka consumer, yeah, you probably should do it that way because Kafka rebalancing behavior doesn't like a whole lot of individual churn. If, on the other hand, you're running a web tier and there's just a bunch of content that's being served out, maybe instead you want to bring up all of V2 and then, once it's healthy, kill off all of V1 and shift traffic over from V1 to V2. That's called a blue-green deploy, and you have that kind of mechanism built in to the control plane, built into ALB. So we can work with ALB and we can direct traffic as containers get to be healthy, direct traffic from old to new, and then once we have no more old containers taking traffic, we can go ahead and kill them off. So infrastructure as code is a practice that I hope you guys are all already following. There are probably two super popular languages for this right now. If you're in AWS, one of them is CloudFormation. CloudFormation is our built-in infrastructure as code language. And this is what's on the screen, by the way. It takes both JSON format and YAML format, so you're able to describe the end state of all of your infrastructure. Starting with blank account, I'm going to need an ECR repository, I'm going to need an ECS cluster, I'm going to need this many instances of this AMI, and so on and so forth, including deploy these task definitions, wire in these load balancers to route traffic, and so on and so forth. You can have absolutely everything described as a CloudFormation template, and then you just open up your brand new, never used account, upload CloudFormation, and everything will be deployed as needed. The other language, by the way, I think Rick alluded to it, Terraform. Raise your hand if you're using Terraform. Not as many as I thought. Interesting. Raise your hand if you're using CloudFormation. All right, just about as many, maybe more. Interesting. Very cool. I don't have an opinion one way or another. I used Terraform before I got to AWS, and today I still use Terraform. But I do love CloudFormation, and I use it for very specific tasks. And in fact, later in the demo, you'll see CloudFormation, not Terraform. So this is a CloudFormation command, AWS CloudFormation create stack. In CloudFormation, the unit is stack, and you can have one stack that describes absolutely everything. But if you're in here, you're probably thinking monolith to microservices. You don't want to build a giant monolithic CloudFormation stack, right? You want to actually have stacks that are smaller that you could potentially work on, fix, replace, update, and have those not necessarily touch the other stacks. So that said, you can have multiple stacks and have them all kind of work together. So this is creating a stack, giving it a name pre-prod, and then passing in a template file. And then when you want to update, you simply change the file, make all your changes that you want, and then you use update stack. And it will take in the file again, process what are the differences, and then calculate how do I get from A to B? How do I get from current state to new desired state? And then it will start working with the services and figuring out how to make those changes. When you need a new environment, you don't have to work through all of your versions of CloudFormation. You simply take whatever the latest copy of your file is and you run create stack again. So you've been iterating in an account and you've done pre-prod and you get it to where, okay, I'm happy with this. So now let's build a production one. Maybe you switch accounts and bring your file over, or maybe you do it in the same file and you build everything with a new prefix called production. Those are, both good options. ECR. So how do I define an ECR repository? On the left, you see JSON. On the right, you see YAML. These are both doing the same thing. I would create, from the command line, create repository, and give it a name. But if I'm going to drop something into CloudFormation, then on the right, I would just use this YAML in my CloudFormation stack. If you need to perform a Docker login, AWS ECR get login, and I'm actually, oh sweet, I can change screens. I'm going to do that real quick just so you see. I talked about this in my first talk of the day, but I didn't demo it, so I want you to understand what's happening here. AWS ECR get login is making a call to IAM, and it's asking for a Docker compatible set of credentials. And these credentials are going to expire. So if I'm not afraid to leave this on the screen because I'm not showing you the whole thing, it's that big. So username is AWS, and password just scrolls for a long time, right? So that's a huge password. So if I took this command and just pasted it into my terminal, I'm basically just running Docker login. I am just running Docker login. So I'm going to log into my registry using a bad password. Whoops. Bad demo. Well, pretend that worked. So the shortcut for doing this is to actually run the command AWS ECR get login. Uh-oh. That's difficult. Let me open a new terminal. And put this whole thing into shell command substitution. Boom, login succeeded. So this is why you don't copy paste things, but also this is really handy. This is easy to automate, and this will log your instance into the ECR registry. So you just have this execute. I think the expiration is 12 hours, so have it execute, somewhat frequently so that your instances stay logged in. But it's a pretty cool, pretty handy feature that effectively marries together IAM security and Docker login security. Okay, so on the CLI, if we need to create an ECS cluster, create cluster. Very simple. In CloudFormation, also very simple, right? It's simply AWS ECS cluster and give it a name. Why do I not have to decide what size does the cluster need to be or anything like that? Anyone have any thoughts on that? Auto scaling? Not quite. What I'm building is the control plane. And with ECS, there really aren't any choices for size of control plane. It's one control plane for the whole region. So you won't outgrow this control plane. We'll see it coming. If you decide I need to build, I need to register 1 million instances and launch 10 million containers, that'd be really cool. I'd love to talk to you as you do that and kind of watch it happen. I've never even been able to do that. I don't have an account with enough overhead that'll let me do that. But we'll see that happening, and we can size the control plane to handle it. And we're doing that for every one of our customers all at once, not you as a customer, or you as a customer, or you as a customer. We're able to do that because it's a multi-tenant control plane and it's built for the entire region. So all you're doing is you're carving off your own little space in the control plane, and you're saying, for my account, I'm building a cluster named preprod. And everything that's happening for me is going to happen inside that little area of your control plane. It's pretty cool. So the cluster becomes just a logical construct at that point. There's really nothing physical about it. Unlike, say, EKS, where when you provision the control plane, we actually bring up instances and we cluster them together, and we have a database dedicated to your control plane that's backing it and all that stuff. In ECS, none of that happens. It's all done for you already. So container instances, I'm not going to spend a lot of time on this slide because I think we get to the specifics in the later slides. But this is a fun slide to look at because what we're doing is we're looking at the entire traffic flow for a VPC. So if you think about, I'm running a web application, I have customers, they're going to hit the internet gateway. Well, I said I wasn't going to do that, right? So here we go. They're going to hit the internet gateway. The internet gateway is going to route their traffic to an ALB, and the ALB is going to route the traffic to healthy container instances. And those instances are part of an autoscale group. So maybe on Black Friday or on some other very high peak day, you run a huge sale, you might need to add instances. Because these are part of an autoscale group already, it's simply an API call to increment a number. You can go from 2 to 3 to 5 to 10 and just keep adding instances of either EC2 instances to give you resources or containers to respond to the traffic. Now, for outbound communication, the container instances, when they need to talk out, like they're starting up and maybe they need to pull in some data, or they need to register with S3 or read some bit of information, that traffic goes out through a NAT gateway and then hits the internet gateway and leaves for the internet. So outbound traffic, the thing to note here is what we're doing is we're putting all of our workload into a private subnet. When we built our VPC, we built it with 2 subnets per availability zone, a public subnet and a private subnet. Everything that goes in the public subnet is something that really AWS manages. It's a NAT gateway or it's an application load balancer. Everything in the private subnet is something where my code is running. I don't want that to be publicly exposed except for the one port that I'm expecting to receive traffic on through the application load balancer. So things in this subnet don't get public IP addresses. Things in this subnet don't talk directly out. So I can't get infected and start listening to some worm control plane or something like that because they're talking out through a NAT gateway instead. So the container instances need to log traffic. So logging, we have built in CloudWatch logs. That's certainly a great option for you. If you have other logging options, maybe you're going to log to Loggly or Datadog or one of the other logging services, that would go out over the internet, NAT gateway out, right? But for CloudWatch logs, the container instances are simply going to write directly to CloudWatch logs. No internet necessary. So we have a reference architecture that can help you build all of this, and in fact there are templates, CloudFormation templates, that will build all of this for you that you can just start with. So instead of starting from an empty text editor, especially when dealing with CloudFormation, this is a very depressing place to start because there's so much to write. Start with a template that already exists. Go to this reference architecture and go from there. Never start from the beginning. So this is where I want to build an application. In fact, I've already done most of the work here, but I want you guys to be able to do this on your own later. So I put this application into workshop format, and it's located at ecsworkshop.com. Total side note, by the way, I've also, with the help of others, built a second workshop for EKS at, can anyone guess? EKSworkshop.com, right? So check those out. If there's one platform that you're more interested in than the other, then focus on that. If you don't know about either of them, explore both workshops. You can run everything you can do in your own account. So you're free to just launch whatever. There are cleanup steps that will help you delete things out of your account once you're done. So if you ever, by the way, another strategy that I like to employ when doing stuff like this, if I have not production stuff in my account, but stuff that I want to keep around, but I want to do something like this temporary, I launch it in its own region. So I'll do all of the work for ECS Workshop in some region that I never use. And by the way, did I tell you we just launched a region today? So I know no one in here is using the Stockholm region yet. So you could potentially run this workshop in the Stockholm region, see what it's like, and then turn around and clean everything up. And you'll know when everything is gone because there's nothing else left in the region. Okay, so what do we need for production? Cost optimization. Actually, let me just stop for a second. I said I would demo this stuff, and then I just breezed right on past that. So at ECS Workshop, we start off with the notion of I need to deploy an application or a set of applications. And it's very common to deploy a front end, and then that front end very often will have a couple of back end APIs that it needs to talk to. So what we did is we just wrote a front end that talks to a couple of back ends. And we did that using 3 different languages because it's good to show examples of being able to containerize basically anything. So the front end is a Rails app, and the back end, one of the back ends is a Node.js app, and then the third one is a Crystal app. Anyone ever heard of Crystal Lang? One hand, that's amazing. I had never heard of it until I wrote this. I was, trying to think of what's another cool language besides Go, besides Rust, because those are all so buzzy these days. And so I started looking around and I found Crystal. It's actually it's like combining Ruby and Go together. You can compile it like Go, but it has a syntax that looks like Ruby. So if you know Ruby, it's really easy to start doing things in Go. And you end up with a deployable single artifact binary that's very small and lightweight and fast. So unlike Ruby, it's fast. So anyway, it's pretty cool. So in this workshop, you simply build out the platform, and this is using a tool, but the tool generates CloudFormation. So if I do this real quick, I have the platform repository checked out in environment, ECS, ECS demo platform. All I've done is defined, again, I'm using a tool, mu.yaml, or mu, and mu has a config, mu.yaml. The reason I'm using this is because we can slidify, we can tell you what the best practices architecture is. There have been enough customers run containers in production now that it's become a standard pattern that's repeatable. So why should it be up to you to write CloudFormation from scratch? Why should it be up to any of us anymore to write that from scratch? This is all boilerplate at this point, right? So let's have a tool that generates it. So that's what Mu decided to do. It came along and it said, okay, let's just generate all the boilerplate, and then for anything where there is a business reason for you to make choice A versus choice B, put that in the config. So like the name of your cluster, that's a good choice, so we'll name it acceptance or we'll name it production. But other than that, everything is just boilerplate. So if I do a dry run, what is this going to do? It's just outputting CloudFormation. So I can look at this and see what would it build for me. And let's actually take a look at some of the files. Template VPC acceptance. So I can, does this look familiar, by the way? This is just like what we were seeing on some of the slides. It's building a VPC. It's allocating IP space for each of the availability zones. It's carving up the subnet appropriately, and so on and so forth, and so on and so forth, to the tune of 752 lines of CloudFormation that I didn't have to write. And any of this that I want to customize, I'm still able to customize, but then I'm only writing the CloudFormation that is mine, that's custom, and the rest of it stays boilerplate. So anyway, I love this tool for this very reason. It will then deploy CloudFormation for me. So the only thing that it does is it writes to the CloudFormation API. So I can walk away from this at any point and just start using the CloudFormation myself. If I take a look at the CloudFormation console, one second. So I was looking at the VPC CloudFormation stack on acceptance. There's VPC acceptance. And this is everything that was built for me that I didn't have to do myself, all from that 2 or 4 line config file, all from that CloudFormation that was boilerplate that it generated for me. It's pretty cool. So from there, we have a cluster built, we have a VPC built, we actually end up building 2 clusters. Best practices would say to build a cluster for acceptance and then a cluster for production, right? Does everyone do that today? You deploy something to acceptance and then you look at it and you sign off and you say, okay, go to production. That's a really good way to do things, and in fact it's a good best practice to follow. What else is a good best practice? CI/CD. Everyone do CI/CD today? It's okay to raise your hand on this one. Do you wish you could be doing CI/CD today? I see some hands. Nice. So this will actually build a CI/CD platform for you because that's a best practice, right? So it uses code pipeline. So if we take a look at code pipeline and just look at all my pipelines, oops, code pipeline, here are all of my pipelines that it builds. So for each of the services that I deploy, it builds a code pipeline. And the pipeline starts with checking out the code from GitHub. So I have, and in the workshop you'll do this, you'll fork each of those repos into your own GitHub account, and then it will build for you a code pipeline that starts with your GitHub account, these repos, check out the code, then move on to build an artifact out of that code, containerize that artifact, deploy it to the acceptance ECS cluster. And by the way, we're doing this on Fargate. So you don't even have to worry about managing the instances in that ECS cluster. There are no instances. Then we test, and this test is really simple, but we do test to see that the code was built or deployed successfully and is running successfully. And then we sit here and we wait. Is it okay to move on to production? And I can issue a review and say, yeah, looks good to me, and approve. And now this code deploy will deploy on to our production cluster. So this is a really good, really easy pattern to follow, and it's very repeatable because it's all boilerplate these days. So definitely check out the workshop, run it in your own account, use it just as an idea, like just, okay, this is what I eventually want to get to. And then if you think about it, you can take this pattern and just keep repeating it over and over and over again. We're doing it for 3 services, but it could just as easily be 300 services, or it could be 3,000 services. It wouldn't really matter. So definitely check this out. How much time do we have? Oh, we're doing pretty good. Okay, so what else would there be to do? So once you get your service running, you're happy, you have a good CI/CD workflow, you're deploying code, you're able to experiment and get stuff out and potentially reject it or iterate on it and move it forward into production. That's a really healthy position to be in. So what do you do then? Well, that's when you get to do some of the fun stuff. So the fun stuff is like, how can I optimize? I love optimization of any kind, but cost optimization I really geeked out over at my last startup. And one of the things that we ended up doing is we actually deployed completely everything onto spot instances. Does everyone know that, does anyone know what a spot instance is? Anyone feel like telling me what a spot instance is? No brave, yes, no? No, okay. No brave souls want to describe Spot. Spot is a way of saving money on your instances by allowing us to provision those instances out of our excess capacity. I'll get into a description offline about how the bidding works and how the market works. But effectively, you could see up to a 90% savings on your EC2 bill. Think about that for a second. 90% off. Not 10% off, 90% left. It's 90% off, up to. So that's really cool. So we actually deployed at my last company all of our infrastructure onto Spot instances. And we were able to cut our bill very significantly, which if any of you guys work at a startup, you know that having the smallest cost possible means that you have the longest runway possible. So that's a really good thing to do. There's also reserved instances. Maybe you're not quite as risky feeling as I was, and so you want to potentially save some money, but have a guarantee that you will always have these instances available. That's what reserved instances can do, and you can see up to a 75% savings. It's more common to be around the 50% savings. The risk here is that you're pre-committing to a certain amount of capacity for a length of time, and that length of time is as short as 1 year to as long as 3 years. So if you can pre-commit, and the biggest savings comes when you then also prepay up front all of the money for the next 3 years, then we'll give you the biggest discount. So you can do that. Now, what some customers have done, at reInvent I gave a talk alongside Duolingo, the chief architect of Duolingo, and he described their situation as being a combination of all 3 instance types. They have a base layer of reserved instances. They know, based on their history, they're always going to need a certain amount of capacity no matter what. And they want that capacity to be at a discount, so they've pre-committed to a certain amount of time, and they're getting a discount on those instances. Then, as they start to burst, they know what their typical patterns are, and so they can predict what their burst should be, and they burst into on-demand and burst into Spot. So when they really need to burst, they burst into Spot. But he showed a graph. He had all this graphed out. It was really cool. There were a few hours each morning, it looked like, where they would have just a thin layer of on-demand. So they're paying the most for the fewest number of instances, and they're getting a huge discount for their burst capacity, and then for their base layer of capacity, they're getting a smaller discount, but still a discount. That was a really cool way to do it, too. You can have multiple ECS clusters, as I've alluded to. You can, again, an ECS cluster is a logical construct. So you can really have as many as you want, and you can use them as an isolation boundary. And you can deploy containers out onto them as needed. So you might have a development cluster and a production cluster, or you might have a batch processing cluster, or you might build a cluster per team. So at my last company, we actually built, every developer had their own cluster. So as they would come on board, it was really simple to say, okay, instead of describing to them how they needed to set up their development environment, what libraries they needed to install and all that stuff, we gave them a Cloud9 editor and a cluster. And it was pre-provisioned for them to have all the services that we run on that cluster. And then any service that they decided to branch, it would pin their branch name to their cluster so that it would continuous deploy any code that they've committed, any code they've changed, but otherwise everything, all the other services were running off of master, running off the production code. So they could see how is my code interacting with the rest of the service. It's pretty cool. Scaling. This is another area where you can start to iterate, start to make improvements. Autoscale groups, they not only exist for instances, but they also exist for tasks. So we're able to actually schedule and increase or decrease, scale up or scale down the number of tasks that are running out on a cluster. And we can do that based on CloudWatch alarms. So anything that you can define as a CloudWatch alarm, you can then use to auto-scale your cluster. So in this example, memory above 75%. If the cluster reservation goes over 75%, that means that we're probably running out of instances and we would like to have more. So add more instances. Then the opposite you might want to do, where, I don't have the opposite, I thought I had a slide for that, where if it goes below 40%, scale in. Take away some instances so that I don't have to pay for those anymore. So you can do all kinds of cool stuff like that. Service auto-scaling, you can again define service auto-scaling and have that be alarm-based as well. So CPU utilization is a very common metric to auto-scale your service against. Once I'm seeing so much traffic that my container is maxed out on its CPU or approaching it, add more. Start to distribute that traffic among more containers, and try and keep the CPU utilization to kind of a middle tier. This is where you define the alarm name that you would set for that. CPU utilization is the service metric. And then if the average is greater than or equal to 50%, for one consecutive period of 5 minutes, scale up. So it's really simple, all these little controls that you have built right into the control plane, and you just bring your logic, and we will figure out how to make this happen for you. Security. So we talk about security. Security is a huge area for us, and in fact, because of that, the next talk is actually about container security. So I won't spend a lot of time here on it because we're going to spend almost a whole hour on it coming up. But some things that you should keep in mind: patching your ECS container instances. We try to make it easy for you to understand when there is a new official AMI available, and we publish that on an SNS topic. So I would build CloudFormation, or I would build automation around updating a CloudFormation template for that. Patching your containers, this is kind of a workflow that I want you to understand both in this talk and for the next talk, because this is really what we're going to be looking at. This is a CI/CD container scanning workflow. So a dev would be working on some code, they would commit that code, and that code would go into the CI/CD process, right? So your CI tool, Jenkins in this particular example, would kick off a scan. In this case, it's using Twistlock. We're going to scan the container looking for any kind of vulnerabilities, and then we're going to report back good to go, or bad, let's fail the CI process. So in the next talk, we're going to do something very similar to this, but we're going to use two scanners. We're going to use we're going to use Claire, an open source scanner, and Anchor, another open source scanner. And we're going to actually build some containers and scan them. Another thing to do with containers is to build a minimal container. So this is an example of a Scratch container. Does everyone, who can tell me what is a Scratch container? Yes, he said, and accurately so, it's an empty Docker image. So we're starting at nothing. And this is really a great place to start from a security perspective, because we only want to put into a container what we plan to use. This is really easy to do when you're using languages like Go or C, where you can statically compile all of your dependencies into a single artifact. But you aren't limited to those. So we're going to take a look in the next session at some other options beyond Scratch that you could still do to hopefully minimize your container footprint. The other thing we're doing here is we are adding an unprivileged user and then setting that user to be used for the rest of the container build process. So when we run this application, we're not running it as root, we're running it as a regular old user. So this is a good option to do as well. That way, if there's a buffer overflow and somebody gains access to the system under this process environment, they'll only be a regular user. They won't be root. IAM roles. This is, again, a first-party integration with ECS where you can attach an IAM role directly to a task definition. So you can imagine if I'm an attacker and I've compromised a container and I discover, hey, I'm running an AWS, I might want to start spinning up bit mining rigs, right? Bitcoin mining rigs. That's actually pretty common. So what can you do to prevent that? Well, if we attach an IAM role to the container that does not allow launching EC2 instances, for example, no launching Bitcoin miners. If it allows launching other containers, then maybe as a hacker I would try, okay, I can't launch an instance, but I can launch a ton of containers, so let me try doing that. But why would a container ever need to launch other containers, right? That's a very special circumstance. So an ordinary circumstance, that probably wouldn't happen, so don't allow that in your IAM role. But what do you need to allow? Maybe you're an API and you need to talk to a database, and you can do that over IAM. Or maybe you need to read some data out of an S3 bucket. So I can grant that kind of access, read-only access to an S3 bucket, a specific S3 bucket. So these are all things that I can grant privileges to on a case-by-case basis, but leave out absolutely everything else. And that way, even if my container gets compromised, there's not a lot that the container would be able to do. Excuse me. Monitoring, logging. You can monitor with CloudWatch, and in fact, we have built into ECS the ability to, with one line in your task definition, ship all of your logs to CloudWatch logs. You also have monitoring of your containers simply in CloudWatch. So you can see CPU utilization, memory utilization, etc., and you can have all of that graphed out and available to you, just with the direct integration. Here we're looking at CPU utilization and corresponding 500 request count. So 500, if you don't know, is a generic HTTP error. So if I'm serving out 500s, there's a problem, most likely. And if I'm seeing, that, hey, I'm also hitting really high CPU utilization, there could be something in my code that's either not responding fast enough or responding with some kind of error that's causing me to serve out 500s. So it's good to sometimes, correlate those two things together and see, is one causing the other. We also, some customers actually like using external monitoring, external monitoring services. Prometheus is a great open source project. It's very popular for Kubernetes users, by the way. So if you're a Kubernetes shop but you're exploring ECS, there's actually an ECS exporter that will take metrics and stuff out of ECS and export them into Kubernetes so you can put all of those things together, and it's an open source project that you can run. I said logging a minute ago. Here's the logging slide. One line. Oops. Oh, yeah, I can't highlight. I'm used to highlighting. One line, log driver AWS logs, and then a little bit of config options for it. Log group Nginx, region, US East 1, and now standard out and standard error for this container will automatically be shipped out using CloudWatch logs. Instead of AWS logs, if you would rather use FluentD, journald, JSON files, Splunk, syslog, just drop that word in. Probably slightly different config options, but as simple as that, and all of a sudden you're shipping logs to those destinations instead. So it's really cool, really simple, and less for you to have to worry about. This is an old screenshot of what CloudWatch logs looks like. Let's take a look. CloudWatch. The Wi-Fi here is not spectacular. All right, we'll come back. Metric filters. This is something that we added to CloudWatch kind of recently. We're actually able to pull out fields from your logs and filter on them, and also now, not on the slide, perform calculations on them. So you can, for example, try and figure out an overall average rate of 500 errors just based on logs that are flying by that include 500 in the error field of their log line. So you can see, oh, I'm getting a whole bunch, I'm getting 10 per second or a million per second, and then you can trigger actions based on that using CloudWatch alarms. So logs, front end, bad. I'm trying to find a log stream that might actually have some stuff in it. And then let's figure out how to scroll so you can see it. It's the resolution of the project. Oh, let me see. Get rid of that. So here you go. You can see that I'm just automatically integrated. I'm getting log information directly into CloudWatch logs. Last little bit. Oh, I'm over. Sorry about that. Everything about everything ECS related. We have an awesome ECS page put out by my coworker Nathan Peck on GitHub. Definitely check it out. If you find resources that are cool ECS related, fork it and open a pull request and add them to this page. Thank you guys very much. We'll take a very short break and then we'll start in with the next chapter.